Chapter 1, Lesson 9 of Geometry. We're going to look at perimeter, circumference, and area. And then we'll look at irregular shapes, and then we'll also talk about exact versus estimate. Perimeter and circumference you're probably somewhat familiar with, so we're going to move rather quickly. The perimeter of a polygon is the sum of the lengths of the sides. So a polygon, which we'll talk much more about later this year, is any figure that has segments as sides. And so to find the perimeter or the distance around, you simply add up the sides of the figure. The area of a polygon is the number of square units it encloses. So every polygon is going to enclose a certain area. The number of square units within that is called the area. Now for these figures we have formulas that we use to calculate the area, and we're going to need to know those and memorize them and know which ones to use in which case. Now circles are a little bit different. Well, let me just review perimeter real quickly. Distance around non-circles, we simply add up all the sides. Now circumference, which hopefully you heard before, but if not, is simply a fancy way to say the perimeter of a circle. A circle is not like a polygon because it doesn't have sides that you can add up, so you have to have another way to calculate it. So we use a different word because perimeter, we tend to think of adding sides. Circles don't have sides, so we use this fancy word circumference, but circumference really is just the perimeter of a circle or the distance around a circle. And we have a special formula. Actually there's two of them, but they are related. The C represents the circumference, so the circumference is 2 times pi times r, and r stands for the radius. And the radius is halfway across a circle, or if you started from the center and walked out to the circle, that would be a radius. Or the circumference is equal to pi times the diameter. Now the diameter is related to the radius in that it takes 2 radii to make a diameter. That's why up in this formula you have 2 radii, but if you put those together you have a diameter. So actually these formulas are related, and you can use either one, and the one you choose to use really depends upon what information is given to you in the diagram that you're working with. So we have squares, which again the perimeter is just adding up all the sides, rectangles adding up all the sides, and circles we're doing 2 pi r or 2 pi 2 pi r or pi times diameter to determine the distance around. Now for a square, to find this area that's enclosed by it, these square units, you multiply the base times the height or the length times the width. Now the area of a rectangle is the same really, it's base times height. The only difference that is that in a rectangle the base and the height are different lengths, so we use a b and an h for base and height. In a square the base and the height are the same, so we actually use s to represent the length of a side times s, the length of another side. Because they're both the same, it's actually squaring the same number or the same value. So these are really the same, base times height. It's just that a square is kind of special because the sides are the same length. So those formulas you need to know and be familiar with, and really the only thing you have to do then is substitute in the values and then calculate the area or its perimeter. Now I do want to talk about a problem like this where we're asked to determine the perimeter of the triangle, and what I want to talk about is how to problem solve as you go through the year. If you kind of think about the problem solving process using these few steps here, then geometry becomes pretty much repeating the exact same thing. The first thing you have to do is in this problem you have to ask, well, it wants me to determine the perimeter. What does perimeter mean? And really you're going to need to do that in any problem. Whatever they're asking you to solve for, whether it be perimeter or area or anything like that, you need to figure out, well, what does that mean? What does that mean? What are they asking me? Once you know that, then you need to know, okay, what values do I need to calculate that? And then once you know what values I need, you then go to the diagram to see if those values are given to you. Now, in the beginning of the lesson, those values will be given to you because they're just practicing using the formula. But as you move into the more difficult problems, then they're not going to give you those values. So in that case, if you're not given what you need, what you have to do then is think about something you've learned earlier that can help you calculate what it is you do need, because it's all interrelated. So it requires knowing what you need for the problem and then learning how to see if it's given to you, and then if you're not, go ahead and determine those values that you need. So in this problem we need to know the perimeter. The perimeter I know is I need to add the lengths of these sides together. Now as I look at the diagram, the lengths of the sides are not given to me. So therefore I have to figure, well, is there a way that I can calculate the lengths of the sides? And with horizontal and vertical sides, we've talked about using the ruler postulate, and then for diagonal sides, we've talked about using the distance formula. So even though the values for the perimeter that I need are not given to me, I can calculate them or determine them based upon things that I've done earlier this year. So I can find the length of AB because it's horizontal using the ruler postulate. I can find that out as 6. I can calculate BC because it's horizontal using, vertical using ruler postulate. And then AC, which is diagonal, I can use the distance formula to determine that. So then I have all 3 lengths that I need, and now I can use those to figure out the perimeter by simply adding those together and getting my answer. So problem solving is really recognizing what I'm being asked, looking for the information that I need. If the information is there, great, substituting into your formulas and then solve. If it's not, then remembering something you've learned earlier in the year to help you then calculate what it is that you need, but they weren't nice enough to give you in the problem. Okay, so tackle some of those, and then we'll move on from there with the next videos.